welcome to Physics Medicine Online Tutorial class. I am your physics tutor, Mrs. Okuma Ijoma. Today we want to look at the kinetic theory of matter. We want to look at the kinetic theory of matter. In our previous class, we discussed the evidences or the proof for the constant motion of molecules, where we talked about dissolving of solid in liquid. We equally talked about diffusion. Then we equally talked about Brownian motion. Now today let's look at these theories. We call them assumptions of kinetic theory of matter. Now, the kinetic theory is a scientific model that helps us to understand the behavior of matter using the properties of what? Molecules. Now, this theory are based on the following assumptions. Number one, we talk about matter consists of small particles called what? Atoms. We have discussed it earlier. We have discussed it before that matter consists of what? Small particles, which we called what? Atom. We say that atoms are the indivisible particle of what? Matter. Now the number two assumption, we have that atoms and molecules, they are constantly in motion. Hence, they have what? Kinetic energy. We say that these atoms and molecules, as we have discussed, that they are moving constantly. They are in constant motion. And because they are able to move, that means they possess what? Kinetic energy. Remember, kinetic energy is the energy a body possesses as a result of its motion. Now, thirdly, atoms and molecules of a substance, they are separated from each other by distances greater than their what? Diameter. We talked about these atoms. We said they are separated from each other. Where we talked about, when you look at these atoms or the crystals, you find out that we said that gap exists between them. So they are separated from each other. Now the fourth one, atoms and molecules of a substance, they attract each other with a force which decreases fast as their distance apart does what? Increases. Now you find out that these atoms and these molecules, we said that they are attracted to each other, and that is why we say they possess what we call intermolecular what? Force of what? Attraction. We are going to see that later. Where in solid you find out that these forces, they are very, very strong compared to that of liquid and the gas. Then number 5 of these assumptions of kinetic theory of matter says that when atoms or molecules of a substance, when they collide with each other, they rebound without losing what? Energy or momentum. Now you find out that these atoms or these molecules, because they are in constant motion, they move randomly. For example, molecules of gases, and as they move, they collide with each other, even with the walls of their container. And as this collision occurs, they collide without losing what? Energy. Then number 6 and lastly, when a substance is heated, the velocity and kinetic energy of the atoms or molecules, they do what? Increases. What does that mean? It simply implies that the average kinetic energy of the molecules, they are proportional to the absolute temperature of the substance. That is, when you increase the temperature of these substances or these molecules, you find out that they do what? Their kinetic energy equally does what? Increases. So as the temperature of these molecules increases, these molecules, they move very fast, and that means they possess kinetic energy. That is why they are able to move faster. Now, we want to look at states of matter. We want to use these assumptions of kinetic theory of matter to explain the 3 states of matter. Now, the 3 states of matter are, you have the solid state, the liquid state, and the gaseous state. And the differences between these states of matter can be explained using this word, kinetic theory of matter. So we want to use this theory to explain the 3 states of matter. In exam, you may be asked to use the assumptions of kinetic theory to to differentiate between the three states of matter. Now we are going to start with the solid state. Now you are going to look at the diagram of the solid state of matter. You can see the intermolecular structures of this solid state. Remember, these atoms or these molecules, we say they are very, very small. Remember, we have estimated the size of this molecule to be very, very small, and we saw the estimate of this size to be 10 raised to power minus 7 centimeter, or 10 raised to power minus 9 meter, which is very, very tiny, that we cannot see them with our naked eye. And that is why we have the direct evidence, which we say by the use of an X-ray diffraction and electron ion microscope, we saw that these molecules or these atoms, they have regular pattern of arrangement. Now the intermolecular structure of solid, you can see them, they are closely packed together. They have definite pattern of what? Arrangement. There is no space that exists between them. They are closely packed. Now a solid consists of atoms which are packed close to each other, and because of that they occupy small or minimum space, usually in a regular what? Pattern. So these solids, they are closely packed together, number one. Number two, they occupy minimum what? Space. Number three, they have regular pattern of what? Arrangement. Now this accounts for high density of what? Solid. So number four, find out that this solid, they have what? High what? Density. Now the atoms of solid, that is number five, they vibrate about fixed what? Position only. So these atoms of solid, you find that because they are closely packed together, on heating, their motion is just what? Vibration. They vibrate at a fixed what? Position only. Another one, we say that they are held together by strong intermolecular what? Bond between them. Now you find out that the molecules of this solid, they are strongly bounded together because they have strong intermolecular what? Force of attraction that are binding them together. And lastly, because of that, we find out that this solid, they have what? Fixed volume, and they have a definite shape. So molecules of solid, they have definite shape and definite volume. So we have seen the properties of the intermolecular structure of solid. Now let's quickly go to that of liquid. So as we are stating it, we'll be able to see the differences. Now for liquid, you can see the intermolecular structure of liquid. You can see that liquid, they have space more than what? Solid. So you find out that the intermolecular forces that are binding them together, they are weak. They are not strong as that of what? Solid. So you find out that these intermolecular forces are weak. Now the molecules of liquid, they are far from each other. That's number one. Number two, the forces holding the liquid molecules together, they are weak compared to that of what? Solid, as you can see in the diagram. Number one, they are far from each other, unlike solid. Number two, the forces holding them together are weak. Now another one, the weak attractive forces between these molecules means they are free to move. So number three, the molecules of solid, they are very, very free to move, unlike that of solid, which we say that they just move in their fixed position. We say that the motion of the molecules of solid is that they vibrate in their fixed position. But in liquid, we can see that they are very free to move. And another one, a liquid therefore flows easily since the molecules are not held in fixed position. So the fourth property is that liquid, they can flow easily, they can be poured. Then another one, liquid, they have definite volume but no specific shape. Unlike solid, we say they have specific shape and definite volume. But here for liquid, they have no specific shape but they have definite what? Volume. They only take the shape of the container. And the last property for liquid is that it quickly takes the shape of the container, as I've explained. So these are the properties of the intermolecular structure of what? Liquid. Now let's see that of gaseous state. Now for gaseous state of matter, you can see the intermolecular structure of gases. You can see this gas a lot. There are many space between the molecule. Look at one molecule, you can see the space. Look at another molecule of gas, look at another one. So you have enough space between them, unlike that of solid and what? Liquid. Now the molecules of gas, they are so far from each other. They are so far from each other. So you can see that they are very far from each other. These molecules of molecules of gas, they are very far away from each other. So as a result of that, we say they are very far from each other, that the greater part of gas is an empty space. Now look at the structure. Now all these places, all these gaps, they are what? Empty what? Spaces. The gap between one molecule of gas and the other, you have enough empty spaces. Enough empty spaces, as you can see here in the diagram. Now the force of attraction between the gas molecules, they are very small, that it can be neglected. Now these molecules of gas, we say that the force of attraction between gas molecules, they are what? Very, very weak. They are very, very weak, that they can be neglected. They are very small, that they can be neglected. That doesn't mean that they don't have intermolecular force of attraction. They have, but they are very, very small, that they can be neglected. We say they are negligible. Now the molecules, they move in straight line at high speed. The molecules of this gas, they move in what? Straight line with what? High speed. So these molecules of gas, they move in a straight line and they move with a very high speed, changing their direction when they collide with each other or with the walls of their container. So because these molecules, they move with a very high speed in a straight line, as they move, they changes their direction, and because of that, they collide with each other, because they move randomly. They move randomly, they move in a random manner. So because of that, as they move, look at it, they are moving straight. Look at the direction of their motion in a straight line, and as they move with a very high speed. They collide with each other because they are moving randomly, and even with the walls of their container. Now the collision of this gas molecule with the walls of the container, that is responsible for the pressure of the gas. So as a result of this collision, these molecules of gas, they exert what? Pressure. There is pressure that being exerted at the molecules of this gas. Now a gas molecule, they have definite volume. They have neither definite volume nor what? Definite shape. So molecules of gases, they don't have definite volume, they don't have definite shape. They only assume the shape and the volume of the container. Remember, for solid, they have definite shape and volume. For liquid, no definite shape, but they have definite volume. Now for gaseous state, they don't have definite shape or definite volume. They only take the volume and the shape of the container. Excuse me. Now we go over to our evaluation questions. Now, having seen the kinetic theory of this matter, the assumptions, remember we call them assumptions. They are being assumed, they are not law. That is why we call them the assumptions of the kinetic world theory. And we have equally used this theory to explain the three states of matter. Now, from previously, what we have done previously, we look at the evaluation question number 1. Describe the experiment to estimate the size of molecule and give an estimate of the size. Number 2, state the 3 evidences to show that molecules of matter are in constant motion. And now, number 3, state 5 assumptions of the kinetic world theory of matter. State 5 assumptions of the kinetic theory of what? Matter. Now, in our next class, we are going to see, in our next class, we are going to look at our next topic. The next topic we have in our scheme, remember we almost exhausted all. We are going to look at solar collector. Now, thank you once again. I remain your physics tutor, Mrs. Okuma. Thank you for your patient listening. See you in our next class.